Assalamualaikum and good day, student. So welcome back to the our FOC. We'll continue to chapter 5, which is mechanism. Basically, this is a bit theory on mechanism. So let's see what we have now. So mechanism and machine. So what is the difference between mechanism and machine? Mechanism is a device which transforms motion to some desirable pattern with a low force. This is the one, low force. This is the keyword, with a low force and little power, compared to the machine provides significant force. Provides significant force. So if you see here, so actually there is a piston, connecting rod and crank over here. So this is the mechanism. So this is called mechanism. So whenever we complete assemble and so on, so we call it a machine. So because it transmit a significant power. Okay, this is some mechanism application. As you can see, this is a crank, and then this is a link over here connected. Because of the link connected together, then it could be applied to the as a wiper system, and then same apply to this piston. So crank, connecting rod. So this is one. This is actually a mechanism application. Okay, a few terms that you should know is link, joint, and kinematic change. So you can read further to understand more on this one. This is the some sort like refreshment on the you refresh back on your dynamics syllabus before. So what is relative velocity method? So what we have here is, like, say there is a rigid body over here, and then point B is the velocity of B is in this direction, and velocity of A is within this direction. Anyway, you still can interpret it by having a velocity of B relative to A in this direction. So velocity of BBA is within this 90-degree angle. Okay, this is the analytical method. Whenever we express this before this is the rigid body, and then this is the direction of BB, and this is the VA. So actually, analytically, we can say that this rigid body is equal to a VA at the same direction, VA, all the rigid body at the same direction of VA, plus this, the angular velocity, the angular velocity. So this is a VBA, the relative velocity. So this is the refreshment on your dynamics. VB is equal to VA plus VBA. Okay, what is this? Okay, what you need to do is this is the space diagram. Space diagram means by having all those mechanism, you can draw or denote the velocity that represent at any point, and then you can transfer it to the velocity diagram. In this case, if you want to know the velocity VBA, you can draw a VAO, meaning that velocity of A from O and the velocity of B from O according to the direction, according to the same direction, and then the distance of this one is actually representing the velocity of B relative to A. This is only direction. This is the velocity of B relative to A, or velocity of A relative to B. So the only difference is the direction, but the magnitude is the same. This is the motion of link. This is actually come from the simple equation where V is equal to R omega. This is R, this is omega. So this is a simple equation as it is. And then this is a rubbing velocity at joint. Like say this is one link, this is another link, this is one pin. So whenever link OA is rotating clockwise, and then link OB is rotating anti-clockwise, and then what we have here is one rod or one pin. So this pin or this rod will facing angular velocity because of this link AO and AB is moving. So there is a equation over here. If the link is moving between different direction, so in this case this is different direction, so the rubbing velocity is equal to R omega 1 plus omega 2. But if the link is moving at the same direction, so the rubbing velocity is R in the bracket omega 1 minus omega 2. You can look further in terms of force acting in mechanism in the in your module and in my slide, so you can study more about this. So this is a basic analysis, basic theorem that may help in solving the exercise or the problems in terms of mechanism. So that's all. Thank you very much.